You are highly welcome. We are looking at the second order linear differential equation. Okay, and this is not the first time we are taking this topic. Okay, we just have a new set of questions. Okay, so the target for this night is to look at the background and begin to solve different questions, different kind of questions on second order linear differential equation. Second order linear differential equation is of this form. Okay, a times a second differential plus p of x times a first differential plus q of x times y equal to what? G of x. So if your g of x is equal to 0, then we call it what? We call it homogeneous second order differential equation. Okay, but if it's not equal to 0, okay, the g of x could be quadratic, could be polynomial, and so on and so forth. Okay, so in such case, it becomes what? Non-homogeneous differential equation. But for this night, we want to look at the case where what? G of x is equal to 0, which is called homogeneous second order differential equation. Okay, want to look at this definition before we go. Want to lay the foundation. Okay, then after that we'll start solving questions. The equations of the form this: a times second differential plus b times first differential plus cy equal to 0. Let's call it equation 1. Okay, this equation is called second ordinary differential equation. Second ordinary differential equation with constant coefficients. With constant coefficients. Okay, our goal is to solve this equation. Let this equation y, let it be the solution to this equation. That we need for us to get the first differential of this solution. The first differential of this, if you differentiate this one, is going to give you this one. Okay, then the second differential, the first differential, this is y prime, that's the first differential. Okay, that's the y, what? Respect to x. You differentiate this equation respect to x. The second differential, that will be this. You differentiate this one again. You differentiate your first differential again, and that will give you what? That will give you r squared e rx. Okay, then you now substitute your first differential, second differential into this equation, and that will be equal to what? So that's what we have there now in this case. So what we'll do now, this one is here, is here, is here. I mean, e to power rx. We can take it out, but 0. And then you can divide the equation by what? By this. So finally, we have what? We have this. So this is called the auxiliary equation. This is called the auxiliary equation. The auxiliary equation is quadratic in nature. Okay, so that we need for us to get the what? To get the solution to this quadratic equation. Okay, so, and don't forget, if you want to solve quadratic equation, we need to consider this will be equal to what? R equal to, for quadratic formula, we have minus b plus or minus b squared minus 4ac over what? Over 2a. Okay, for us to solve this auxiliary equation, which is quadratic, we are going to use this quadratic formula. Okay, and consider 3 cases of this quadratic equation to get the root of the equation. Okay, so that's what we have now. We are going to look at the 3 cases, and the first case we want to look into, case 1, is when the discriminant when b squared minus 4ac is positive, is greater than 0, when b squared minus 4ac is greater than 0, what is going to be the solution of the quadratic equation? I mean, of the auxiliary equation. Okay? So if your discriminant is positive, is greater than, you have two distinct real roots. Case 2. Case 2 is when the discriminant b squared minus 4ac equal to 0. Okay, so in this case, we're going to have one real root, which means we're going to have R1 is equal to what? Is equal to R2. Okay, the solution of the auxiliary equation, okay, R1 is equal to what? R2, which you can see is equal to R. So that's the case 2. Okay, for case 1, the general solution, let's go there. The general solution for case 1, let's get that. We're going to have y1 equal to e to power what? R1 times what? Times x, and y2 equal to what? E to power what? R2 times x. So these are the roots of the auxiliary equation. So the general solution for case 1 will be equal to y equal to what? C1, which is a constant, times y1 plus C2 times y2. The y1 is this, the y2 is that, for the case of real roots. For case 2, when you have the discriminants equal to 0, which is going to give you a real root, one real root. Okay, so in this case now, what happens here is that we call it when b squared, for case 2, your discriminants, okay, is equal to 0. So it's giving you repeated roots in such that R1 is equal to what? R2. Okay, so we're going to have y1 equal to what? Y1 equal to e to power what? R, because R2 is the same as what? As R. So we're going to have this for the y1 equal to what? X ERX. Okay, because I believe my function and my quadratic, so that's that. Then the general solution is this. The general solution is y equal to C1 y1 plus C2 y2, which is equal to C1, my y1 is this, plus C2 ER. Okay, so this is a case of repeated roots when you have discriminants equal to 0. Then the third case is when the discriminants, okay, is less 0. When your discriminants 4ac, b squared minus 4ac is negative. Okay, in such case, it's going to give you what? Your root will give what? The root of the auxiliary equation will be what? Will be complex function. Okay, it's going to give you two distinct complex roots. You have the real part. This is a complex number. Okay, we have the real part, which is the alpha. We have the imaginary part, which is this part. This is the imaginary part where you have the I. So we can split this one to 2. We have R1 equal to what? Equal to alpha plus beta I. and then R2 equal to what? Alpha minus beta I. So these are the roots, the two roots for the case of b squared minus 4ac less 0. This is when the discriminants, this is what we call the discriminants, b squared minus 4ac is negative. Okay, then you have what? Two distinct complex roots. Two distinct complex roots, which is what? Alpha plus beta I and alpha minus beta I. So that is the case of this. Then the next thing to do now is to get the what? The two roots, okay, of this form and the general solution. Okay, then after that, we begin to play with questions. The general solution for case 3 is going to be, we're going to have one of the roots, y1 equal to e to power alpha x. The alpha is the real part, cos beta x. Okay, y2 is equal to what? Alpha e to power alpha x sine this. Let me explain that. The alpha is the real part, just like you have, maybe by the time you solve your auxiliary equation, you now have 3 plus or minus 2i. For instance, okay, you have that. This is the real part, and that's the alpha. Okay, the imaginary part, the attachment to your I is the beta. Attachment to I is what we call the beta. Okay, then just make the substitutions to these y1 and y2. Okay, and the general solution will be what? The general solution will be equal to c1 times what? Times y1. That's a y1. This is a y1 plus c2 e to power alpha x sine beta x. This is your y2. So that's the solution for the case of two distinct real roots when the discriminant is negative, is less than 0. So that's that on this case. This is the question we have. We have to find the general solution of the differential equation. Find the general solution of the differential equation. We have this is a third differential. This is a fourth differential equal to 0. And we have the initial value conditions. Okay, we have the initial value conditions, which we call the boundary conditions. We have y of 0 equal to 0. Okay, and I'm going to explain that to us. Let's see solution to that. Okay, before y of 0 equal to, this means when x is 0, y is what? Is 0. Okay, this is first differential. Okay, for first differential, when x of the first differential is 0, the first differential is what? The y of the first differential is 1. Okay, when the second differential, okay, the x function there, when it's 0, the second differential value is 2. So we're going to look at this case. So the first thing you do is this is already homogeneous, is equal to 0. Okay, so what we're going to do here is to get the characteristics, get the auxiliary equation. Get the auxiliary equation, or characteristic equation. Get the auxiliary equation. That's step 1. Get the auxiliary equation. And how do we do that? We're going to, without wasting time, we're going to correspond your first differential as r, your second differential as r squared, your third differential as r cubed, and the list go on like that. Okay, first differential as r, second differential as r squared, third differential as what? As R cube. Okay, so that's what we have there. Then the auxiliary equation will be equal to what? The auxiliary equation will be R cube plus R equal to 0. And we're going to factorize this. One of them is common. R is here, R is here. Take it out. Take one that is common, take it out. We have R squared plus what? Plus 1 equal to 0. And this implies R is 0 or R squared plus 1 is equal to 0. Okay, already we've gotten this one. Okay, we can stop this one. So R squared is equal to what? Minus 1. Okay, then we can take the square root of both sides. So R is equal to what? Plus or minus square root of what? Minus 1, which is equal to what? Plus or minus imaginary number I. Okay, so this implies, this equation implies the real part is 0. We only have the imaginary parts. Okay, we only have the imaginary parts. And in this case, the beta here is what? Is 1. The coefficient of I is what? Is 1. So this is alpha. This one is your what? Is your beta. Okay, that's your beta. So without wasting time, this one will generate y1, which is equal to what? Which is equal to e to power what? E to power r. Don't forget rx. So it's going to be what? It's going to be equal to 0x. Okay, and that is what automatically what? This is 1 for this case. Okay, for this case, for these roots, okay, R2 will be equal to, don't forget, this is the case 3, where we have two distinct complex roots, okay, or complex number, okay, plus or minus. So it's going to be equal to what? It's going to be equal to, we're going to have E, I mean the Y2, Y2, we've already gotten Y1, so this will be Y2 and Y3. This will generate 2 and 3. So we have the real parts, that's the alpha is 0, x, cos beta is 1. So times what? Times x. And then y3 is what? Y3 is equal to what? E to power the real part, which is the alpha, that's 0, sine what? Beta x, which is what? Which is my beta is 1. Okay, so this one will be equal to what? Cos x. This one will be equal to what? Sin x. The general solution will be equal to y equal to c1 times the y1 plus c2 times the y2 plus c3 times what? Y3. And that will be equal to what? That will be equal to, my y1 is what? Is 1. I have c1 plus c2. My y2 is what? Cos x plus what? Plus c3. My y3 is what? Sin x. Sin x. Okay, so that's that. As you're coming in, just begin to say I. As you're coming in, just begin to say I. That's not the end of the solution. We need to get the first differential of the general solution. We need to get the second differential of the general solution so that we can get the value of C1, C2, and C3. The essence of these initial value or the boundary condition, the essence of this condition is for us to get the what? C1, C2, and C3. Okay, C1, C2, and C3. Please subscribe straight away. If this is your first time, subscribe straight away. Begin to share the links across your different platforms Begin to share the links across your different platform. Share, 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 share. Begin to share the links across your different platform. Share the links across your different platform. Share the links across your different platform. Share, share, share. Okay. If you're coming here for the first time, subscribe to the channel. Subscribe to the channel. If you're coming for the first time, please endeavor to subscribe so as to keep track of the updates of this channel. Share, 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 share. Give the videos a thumbs up. Give the videos a thumbs up. Begin to share the links across your different platform. Begin to share the links across your different platform. We've already gotten the general solution. So we need to get the C1, C2, and C3. And how do we do that? We need to use the what? The initial value condition, the initial value given to us. Okay, we need to use that. The first thing we are told is that when we have this, let's say this one, what's the interpretation of this? This means when x is 0, y is what? Y is 0. Put it there. That will be 0 equal to C1. We have our C1. Okay. Cos x, which is a 0, that's what? That's 1. That's a plus C2. Sin 0 gone. That's what? That's 0. So we just have this one. Call this one equation 1. Call that one equation 1. So that's what we have in the first case. Then let's now go to the first differential. Differentiate your general solution. Differentiate that y1, y prime equal to. This one is a constant. There's no variable there. So that's 0. Then we have this one. C2 is a constant. When you differentiate cosine, that will be minus C2 sine what? Sine x. And then plus C3. Okay, when you differentiate sine, it's going to give you cosine. Okay, that's a cos x. I mean, when you differentiate sin x, it's going to give you cos x. Okay, so that's what we have there. Then we can make substitution of the initial value condition. Y prime, when x is 0, y is what? Y is 1. Okay, so we're going to have now 1 equal to x is 0. So this may displace to what? That one disappear. We have C3 in this place. Cos what do you call it? Cos 0 is 1. So C3 is what? Is 1. We can get the second differential. We can get the second differential. The second differential will be equal to, differentiate your sin x, which will be what? Which will be minus C2. Okay. Cos x. Okay. And then plus, that will be minus. So if you differentiate cosine, that will be minus C3 sin x. Okay. Then you can make your substitution for that place. Second differential at the condition given x is 0, the second differential is 2. So we have 2 here equal to cos 0 is 1. We have minus C2, and this one will disappear. So another value. So we've gotten C2, we've gotten. So final conclusion, come back and make your substitution. Make your substitution equal to my C1, I don't know, for my C to minus 2. So C1 is a 2. Share. Don't keep it to yourself. Begin to share across your different platform. Begin to share across different platform. There is love in sharing. Begin to share across a different platform. Okay, this is a second order uh, linear differential equation. We're looking at the homogeneous second order differential equation. Homogeneous second order differential equation. Second order homogeneous second order differential equation. Begin to share the links across your different platforms. Share, share, share. If you're yet to subscribe, please do so now. Begin to subscribe right now. The characteristic equation or the auxiliary equation for the first differential, I've said that first differential, y prime, that's r. Second differential, that's r squared, and it goes on like that. So this will be r to the power 4 minus 4 times third differential, that's 4 times r cubed, okay, and then plus 4 times second differential. Second differential is r squared equal to what? Equal to 0. This is a homogeneous second order differential equation. Okay, so what we do here is to r squared is common, take it out, then we have this minus 4r plus 4 equals to what? Equal to 0. Okay, so we are having r squared is equal to 0, or this one, okay, is equal to 0. So this will be equal to what? We are going to split this one into 2. So this will be equal to r1 is equal to 0. Okay, r1 from here we can get 2 roots here. So r1 is equal to r2, and that's equal to r, and that's equal to what? That's equal to 0. Your r1, your r2, they are the same. So this is repeated. This is repeated roots. This is repeated roots. Okay, and then for this equation, r squared minus 4r plus 4 equals to 0. We're going to have r minus 2. Okay, r minus 2 equal to 0, because the factors of 4 is 2 and 2. Okay, if you multiply this one and this one, we have this. Okay, and the factors of 2 factors of 4 is 2 and 2. That can generate minus what? Minus 4, and that will be minus 2 minus 2. Okay, so and when you multiply that, you're going to get back your 4r squared. Okay, so r is also equal to what? R, this will be this is equal to 0. This is equal to 0. So r3 and r4 is a repeated root also, is equal to what? Is equal to 2. This is also what? Repeated roots. This is repeated roots. So for r squared, we are going to have y1, which is equal to what? E to power 0x. Y2 is equal to what? E to power, that will be x e to power 0x. R minus 2, we have r is equal to what? R3 and R4, they are repeated roots. So we have e to power 2x, y4, that's x times e to power 2x. Okay, so the general solution is equal to what? C1, y1, C2, y2, C3, y3, and then plus what? C4, y4. Okay, so that's the general solution. Then we can begin to plug in what we have. This one is 1. This one also is what? Is x. So we have C1 for this case, for this one here, C1 times 1 plus C2. My y2 is what? Is this, plus C3 times what? E to the power 2x plus C4, which is what? X e to the power 2x. So that's the general solution for that case. That's the general solution for that case. We need to get the first differential. Get the first differential. which will be equal to what? If you differentiate this one is a constant. That one is gone. We have C2. Okay. Differentiate this one. That will be 2 times C3 into power 2x. Okay. And then this one will be a product rule. Okay. That will be plus, I'm going to differentiate the x, and I have a C4 e to power 2x, then plus. Now keep the x constants. So we're going to have 2C4, keep the x constants, and then why you differentiate e to power 2x. That's the first differential. That's the first differential. Okay. When x is 1 is 2. Okay. The first differential when x is 1 is 2. Okay, so we have C2. Okay, then this will be what? This will be plus 2C3 e to power 2. Okay, plus you can combine these two together. Okay, they are not the same. They are not the same. That will be C4. This will be C4 e to power 2, and then plus 2C4 e to power 2. Okay, so that's what we have there for the first differential. When you make your substitution, if you want the solution to be continued, let me know in the comment section. But I've laid the foundation. The foundation has been laid. Just continue from there. Get your second differential, your third differential. Okay. Another question. What we're going to do in this case, we have to find the general solution of the differential equation. Okay, and the highest order in this question is 3. This is a third differential times 4, and then plus fourth differential plus 5 times y. So what we're going to do, and then we have the conditions given. Okay, y of 0 is 2. First differential of 0 is 1. Second differential of 0 is minus 1. Okay, let's see the step 1, the auxiliary equation, which will be equal to 4 times. This is a third differential. That will be r cubed plus this one is the first differential. That's r. So when there is no differential, you just write the what? The constant coefficient, which is what? Which is 5. Equal to what? Equal to 0. So that's what we have there. Let me check the question again. That's what we have there. Okay. So what we have here is polynomial. What we have here is a polynomial. This is a polynomial. So we are going to take the 5 and look for the factors of 5. Okay. Factors of 5 could be 1. Okay. 1. Factors of 5, 1. Okay. And also 5 also. 5 is also the factors of itself. 1. Okay. So it could be plus or minus 1, and then plus or minus 5. So we are going to, this function, we're going to call it as a functions of r. Okay. It's a functions of r, which is 4r cubed plus r plus 5. And we're going to use this polynomial. We're going to use a factor theorem. We're going to use factor theorem. Okay. We're going to look for these factors, plus or minus. Okay. Let's check. Let's make a substitution for minus 1. Okay. If this is equal to 0, let's do that. This will give you minus 4. This will be minus 1 plus 5. This is equal to what? This is equal to 0. Okay. Therefore, r plus 1 is a factor. R plus 1 is a factor. Okay. If I use plus 1, Okay, and I substitute and I get 0. That will be what? That will be r minus 1 is what? It's a factor. Because if you equate this one to 0, you're going to get what? R as what? Minus 1. So when you've gotten the factors now, then you now use a long polynomial long division. Okay, that will be equal to what? Yeah, that will be this one, r plus 1. Then you write your function for r cubed plus, plus 0 r squared, and then plus r plus 5. Power 3, power 2, power 1. Okay, so and then you do your long division, and then you take the first one of the polynomial, and then you divide by the what? The first one here. Okay, and that'll be what? 4r squared. And then use it to multiply your divisor. 4r squared times r, that's a 4r cubed. 4r squared times 1, that's a plus what? Plus 4r squared. Do your subtraction. This will cancel. 4r cubed minus 4r cubed, that's 0. And we're going to have here minus 4r squared. Take it out, you bring it down. The next value, you bring it down. Repeat the process also. 4 minus 4r squared over the first one here over r. That's what that's minus 4r. Okay, and do the multiplication. This one times this one, we have this one. Minus 4r times plus 1, that's what? Minus that's a minus minus 4r. And you do your subtraction. Minus this, minus this. That's 0. R minus 4r. That's plus 5r. And then you bring the next one, you bring it down. That's what? That's a plus 5. Okay, repeat the process also. 5, the first one, 5r over the first one of your divisor, and that's giving you plus what? Plus 5. So 5 times r, that's a 5r. 5 times 1, that's a plus 5. So when you subtract, it will be 0. And then the remainder is what? Is 0. And this confirms r plus 1 is a factor. Okay, so the polynomial will now become f of r is now equal to r plus 1 times what? 4r squared minus 4r plus 5. Okay, so that's what we have in that place. Okay, so that's the f of r, which is equal to what? Is now equal to 0 now. Okay, we're going to factorize this quadratic equation. Let's see if we can factorize that. Let's see if we can factorize 4r squared. Okay, this one is already linear. Okay, so this one also want to turn it to product of two linear equation or expression. So this will be equal to, let's check this one, plus 5. Multiply this one, the first one, and the last one, that's a plus 20r squared. Then look for two factors of this that can generate minus 4. Two factors of that can generate minus 4. Factors of 20, that will be 10 and 2. 10 and 2 can never give us minus 4. 4 and 5 also can never give us minus 4. So we can't factorize it, but we can use the formula method to get the root of this one. Get the root of this one, because this one implies r plus 1 is 0. So r is what? Minus 1 for this case. And second one, 4r squared minus 4r plus 5 is equal to 0. And we're going to solve this one using quadratic formula. Okay, a is what? A is 1, a is 4, and then b is minus 4, and then c is 5. Okay, so let's substitute that into the quadratic equation. Minus b plus or minus b squared minus 4ac over 2a. Let's make the substitution in that place. Make the substitutions, and that will be equal to b, that will be 4 plus or minus 4 squared, that's 16. 4 times minus 4 times a, that's a 4. A is 4 times c, that's a 5 over what? Over 2 times 4. So we're having 4 plus or minus 16. 4 times 4, 16 times 5, that's 80. So 16 minus 80, that's a minus 64 over 8. Minus 64 over 8. And that will give us a 4 plus or minus 8i over what? Over 8. And that will give us 1 over 2 plus or minus I. 1 over 2 plus or minus I. So the 1 over 2 is the alpha. The attachment to the I is 1. So beta is 1. Beta is 1. So this is giving us two distinct complex roots. That's giving us two distinct complex roots. So we can say this is R1, make it R1. R2 is what? Is alpha plus I. R3 is what? Alpha minus I. Okay? So that's what we have there. Will be equal to y equal to C1, Y1, C2, Y2 plus C3, Y3. And that will be equal to, for Y1, Y1 is e to power minus 1. So that's minus x C1. Okay, don't forget my y1 is equal to e to power r1x, and my r1 is what? Is minus 1 plus c2. We have the real part, so that will be e to power the real part. The alpha is the real part, that's the alpha x, and then cos. My beta is what? Is 1. So that's what? Cos x, that's a c2, and then plus c3 is what? C3, my y3 is what? E to power half x cos what? Sine beta. Beta is 1. So that's that. So that's that. Don't forget, we said when you have two complex roots, you're going to have, that will be y1 equal to what? E alpha x cos beta x. Okay, y2 we got what? E alpha x sine beta x. My alpha is half. Okay, so my beta is what? Is 1. And that's what we have done for the second equation, for this one, for the root of that equation. Okay, so the next thing to do now is for us to get the first differential. Get the first differential of the above equation. Get the first differential, and that will be minus c1 e to power minus x. This one also get the differential. This will be product rule, that will be plus half, okay, c2 e to power 1 over 2x. I'm taking cosine in the first case as a constant. I'm differentiating the e function. Then now keep e function constant now. That will be plus, when you differentiate cosine, that will be minus, c2 e to power 1 over 2x, and then sine x. So I'm through with this one. I'm through with that one. Okay, I'm through with that one. So I'm going to the this one, the C3, to differentiate that. I'm going to C3 to differentiate that. So that will be equal to plus, let's differentiate the e function. That will be half C3 e to power 1 over 2x. Keep your sign constants, and then plus. Now keep the e constant now. Differentiate your sin x. That'll be C3 e to power half x cos x. So that's the first differential. We're going to get the first differential. We're going to get the second differential. Get the first differential. Get the second differential. Okay? If we like, we can combine these two together, and then there is no time for us to do that. We can continue straight away. Second differential as a function of x. Differentiate this one. That will be C1. The derivative of the e function is -1. So we have that. Okay. Differentiate this one, the e function. That'll be plus 1 over 4. When you differentiate the e function, keep the cosine constant. So times half. So that's 1 over 2 times 1 over 2. C2 e to power this. Keep your cosine constants. Okay. Now keep the e function constant and differentiate the cosine, which is minus. So that will give us minus half C2 e to power 1 over 2x sine x. So I'm done with this one. I'll come to this place now. So that'll be minus half. When you differentiate this one and here, differentiate the e function. That's the e to power 1 over 2, 1 over 2x. Okay, C2, don't forget your C2. Okay, sine x. And then minus, don't forget, it's a product rule, but there's a minus here, which will affect everything inside. So that will be what? Keep the e function constant, differentiate the sine, that will be C2 e to power 1 over 2x cos x. So I'm done with that. I'll come to this one, repeat the process there. To what? Plus, differentiate the e function, that will be 1 over 2 times 1 over 2. That's a 1 over 4. That's 1 over 4 C3 e to power 1 over 2x. Keep the sign constant. And then plus. Now differentiate the sign now. So that's 1 over 2 C3 e to power 1 over 2x cos x. And finally, come back to this one, and that'll be what? Plus 1 over 2 C3 e to power 1 over 2x. Keep the cosine constants, and then plus. Now keep the differentiate your cosine now. Keep e constants. So that will be C3 e 1 over 2 x sine x. So this will be minus. So this is minus. So that's what we have with the second differential. Let's now begin to substitute those values there. Y is 2. Y is 2. X is 0. So if you substitute, we are going to have C1 here, cos 0 is 1. E to power 0 is also 1. So we have C2 plus C2 plus C2, and then plus. This one has spoiled everything. Sine 0 is what? Is 0. So everything here is what? 0. So we have first equation. The first differential condition, boundary condition, the initial value. Okay, s is also 0 there. Go to your first differential and substitute this one equal to 1. X is 0, and y is what? Y is 1. I mean, the first differential is 1. Okay, so let's do that. So that will be equal to, first differential is 1. We have 1 equal to, that will be minus C1. I'm here. First differential, I'm here. This is 0. That's this is 1 times minus C1. plus, because 0 is 1. This one is also 1. So I'm having half plus half C2. Sin 0 gone, cancel. Sin 0 also cancel. So we are here. That's a plus what? C3 plus C3 because cos 0 is 1. E to the power 0 is also 1. That's second equation. Then for the second differential, I'm here for second differential. Substitute your initial value, the boundary condition. Let's substitute that. So that will be equal to, this will be e to the power 0. That's 1. So we have minus 1. The second differential is a minus 1. That's C1. Okay, C1. That's C1. Here, that will be plus 1 over 4 C2 plus 1 over 4 C2. Here, sin 0. So this one cancel. That's 0. This one also cancel. Okay, so we have what? We have minus C2. Minus C2 in that place. Okay, this one also cancel. Sin 0 is gone. That's 0. Here we have half C3 plus half C3. Okay. Here also plus half C3. Okay. And finally, this one cancel. Sin 0 is 0. Is 0. So that's that. So we now have these three equations. We have these three equations. We have these three equations to solve. But let's tidy up this one. We're going to have minus 1 equal to C1. This is 1 here. So 1 over 4 minus 1. That would be minus 3 over 4. Minus 3 over 4 C2. If you combine these two together, minus 3 over 4 C2. This one also half plus half. That's a plus C3. So this is your third equation. So that's the equation we have now. That's the three equations we have. So what we can do, we can combine equation 2 and 3. Okay? We can combine 2 and 3 and eliminate C3. Our target is to eliminate what? C3 from this place, from the equation 2 and 3. Okay? Please, as you're coming in, just begin to say hi. If you're yet to subscribe, please do that right now. If you're yet to subscribe, please subscribe. Subscribe to the channel. If you're yet to subscribe, please do that right now. Subscribe to the channel. Okay? What I'm going to do, for me to cancel C3, I want to eliminate C3. I'm going to say subtract equation 3 from 2. From 2. Subtract equation 3 from 2. So I'm going to have, for this one, 1 minus 1. I'm going to have 2 of this is from 2. It means equation 2 minus 3. So that'll be minus C1 minus C1. That's a minus 2C1. Okay. Then C2. For the case of C2, 1 over 2 half minus 3 over 4. Okay, that will be half 1 over 2 plus 3 over 4. And that will give me 4 plus 6 over 8. That's a 10 over 8. And that's a 5 over 4 plus a 5 over 4 C2. C3 minus a C3 cancel. So I've gotten another equation which I can say 4. Okay, but my equation 4 is gotten from 2 and 3. So I have C1, I have C2. And I can combine equation 4 and 2 together. But before I do that, Let's cancel this fraction from here. Multiply through by what? By 4. And that will be equal to what? Don't let me call it 4 yet. Cancel this fraction. That will be times 4. That's 8. Times 4 minus 8c1 times 4. That's 5c2. Equation 4 now. Okay. You can combine equation 4 and equation 1 together. You can combine equation 4 and equation 1 together. Combining equation 1 and 2 together. So we have 2 equal to C1 plus C2. That's my equation 1. And the other one is 8 equal to minus 8C1 plus 5C2. Equation 4. My equation 1, I will multiply by 5 so that we can cancel C2. So times 5. So I have 10, 5C1 plus 5C2. Call it equation 1, equation 5. So now combine equation 4 and 5 together. Combine 4 and 5 together by subtracting. You can subtract them. Subtract equation 4 minus 5. That will be minus 2 equal to minus 8c1 minus 5c1. Okay, 5 minus 5 cancel. So I have minus 2 equal to minus 13c1. So c1 is equal to what? 2 over 13. I've gotten c1. I've gotten c1. Okay, c1 is gotten now. C1 is gotten. Then the next thing to do now is to make substitution to anywhere we have c1. Okay, we can go back to, we can use equation 4, we can use equation 1. Okay, we can use equation 1. So using equation 1, so we have 2 equal to, my C1 is 2 over 13 plus C2. So C2 is equal to 2 minus 2 over 13, which is 26 minus 2 over 13. And that's 24 over 13. That's the C2. Finally, let's look for where there is a C3. Where we have C3, and that is this place, equation 3, using equation 3, and get the C3, using equation 3, and get the C3. I want to say, this is one of the, this question is very tough, it's long, okay? This is an exam question somewhere else, okay? This is an assignment somewhere else, okay? I want to play with you to sit down and begin to follow with your writing material. 3 over 4, and then plus what? Plus C3. Okay? So we're going to make C3 the subject. Minus 1 equal to this. Two year 1, 2 year 12, or even 4 year 1, 4 year 6. So that's minus 18 over 13 plus C3. Okay, so we can solve this one. That will be what? Minus 16 over 13 plus C3. So C3 is equal to minus 1 plus 16 over 13, which is equal to yeah. So that's that on that question. So that's that on that question. Okay. So the final thing to do is to write the general solution. Thus equal to, the general solution will be equal to, without wasting time, begin to substitute your C1. Your C1, this will be equal to, if you check a general solution, plug in there, check your solution. So this is your final conclusion. That's the final conclusion for the general. That's the general conclusion for the general solution. As a breakfast, we'll continue. If you have questions, I'll continue tomorrow morning by the grace of God. Thank you for subscribing. Thank you for sharing the links of this video across your different platforms. Thank you for subscribing, for likes, okay, for like, for sharing, and for subscribe. And if you're yet to do that, please do so right now.